Okay, we're going to go over drawing parabolas by hand. Okay. Now, obviously, we could graph them. We could use a table of values to solve them. But I want us to recognize that when we're in our vertex form, okay, and our vertex form reads y is equal to a x and then minus h squared plus k. Okay. When in this form, we can easily graph a parabola. Now, we're not going to talk about h and k right now. We're actually going to specifically talk about a, which is essentially multiplying our parabola by a value. And there are three different forms. We're used to seeing vertex, standard, and factored form. And the a is always the same number in all of them. It'll be essentially the term attached to our x squared. To draw the standard, or sometimes known as a parent function, y equals x squared. Okay. In this case, there is no h and no k, which means what are the values of h and k? Not 1. 0. There's 0 in this case. And the h and the k tell us directly where the parabola is. The h is our x value of the vertex, and our k is the y value. So if they're both of value 0, that means we're at the origin of 0 and 0. So we're always going to try to plot our vertex first. So we have our vertex. Now there are two ways we can go about drawing this. Now keep in mind, there is an a value here. Anyone know what number this is? That is 1. That's the only one that when there's nothing there, we go with the assumption it's 1. Because if it is 0, then there's no parabola. So when a is a value of 1, this is what you have to go about thinking. There are two ways we can do this. One of the ways we can do this is we always go back to the vertex. Okay? Now, however many steps I go over from the vertex on the x, I square that value. And that'll tell me how much to go up. So, if I go over 1, what is 1 squared? 1. Okay? Now, technically, I should always then multiply that by the a value. But in this case, what is the a value? And multiplying by that 1, is that going to change anything? No. So I'm going to say it every time, but you're going to notice it doesn't change anything. So we go over 1, we go 1 squared is 1, and then 1 times 1, because the a value is 1, still 1. Let's go the other direction. I go back 1, so negative 1. What's negative 1 squared? Positive 1. Times our a value? Still positive 1. So we go back 1 and then positive 1. Okay. After I do that, and you'll notice that we don't actually have to test both sides because parabolas are symmetrical. We go back to our vertex. This time we're going to go over 2. I'm going to have to square that value of 2. What's 2 squared? So that's telling us to go up 4. I then have to multiply by my a. Does that change anything? Not in this case. So we go up 4. And if I were to go negative 2, I'm just going to say this out loud. What is negative 2 squared? 4 times 1 is 4. Great. Go back to that vertex again. This time we go over 3 units. We've got to square that. 3 squared is times the 1, still 9. So we go over 3 and up 9 units. And because we know it's symmetrical on the other side, I know I'm just going to be at 9 again. So here is our standard parabola. Okay, now there's quite a few steps to remember in that one. Another one we can do is a pattern. Another way we can do this is a pattern. And sometimes they refer to it like this. You go over 1, okay? You go up 1. You go over 1 more. You go up 3. You go over 1 more. You go up 5. You go over 1 more. How much would you go up? That's right. You go up 7 from there. Okay? So on both sides, we go over 1, up 1. Over 1, up 3. Over 1, up 5. Over 1, up 7. What about after 7? How many would we go up? 9. Okay, so we continue that pattern of increasing the amount we go up by a value of 2. Either of these will help us draw it. Now, many people find this version easier. Okay, whatever you like is best. Now, what we're going to do is we're going to work when our a value is a number other than 1. So in this case, our a value here is going to be, let's say, 2. Okay, so we have 2x squared. Now I need to draw this 2x squared. So I'm actually going to go to a different page just so that we have a clean sheet when we're going about doing this. So we're going to start again. In this case, what are the h and k values? 0, there's nothing there. So our parabola's vertex is still at 0. But in this case, our a value is 2. And that's important. Okay? So what we're going to do here is, I'm actually going to use that pattern version to draw this, and then we'll verify it with the squaring version. Okay? So the pattern version was to go over how much? 1, and go up how much? 1. Okay. But we must multiply the amount we go up by whatever our a value is. So what would be going up 1? What is 1 times 2? 2. So we actually go over 1 up how many? 2. That's right. We go over 1 up 1, 2. So here's our new point. And we would do the same thing on the other side. And just to make that clean, that part. Then from there, remember the pattern is over 1 up 1, over 1 up how many? 3. Well, this 3 we got to multiply by our a value. So we go over 1 up 6 instead. Okay. So we have to continue to remember our pattern. I go over 1, we go up 1, 2, 3, 4, 5, 6. So there's our new point. And again, we know it's symmetrical. So go over 1 up 6. Normally from there, we'd go over 1 up how many? No, 5, that's right. We got to multiply it by our, how many should we go up now? 10. Now obviously that's going to fly off the chart. Okay? So if you notice, this parabola, it's a little harder to see right now. This is thinner. It's been stretched because the a value is greater than 1. So because the a value is greater than 1, we have a stretched parabola. Let's say I have another value. Y is equal to negative 1/2 x squared. Where's our vertex going to be? Our vertex is still going to be at 0. But now we have a negative a value. And it's also smaller than 1. Whenever a is less than 1 but greater than 0, we have something that's called compressed. Okay? So it's going to be wider. Think of like compressing an elastic band or stretching an elastic band. So this one we're going to do by our squaring rules. I go over 1, what is 1 squared? 1. Then I have to multiply by a value. What's 1 times negative 1/2? What's 1 times negative 1/2? What's 1 times any number? Negative 0.5, so negative 1/2. So we go over 1. And because it's negative, we go down 1/2. Okay, so we don't go down as much as we're used to going down. We go down 1/2. We do the same on the other side. Normally, we go back to the vertex, over 2. What's 2 squared? 4. What's 4 times negative 1/2? First of all, what's a positive times a negative? Negative. And 4 times 0.5 or 1/2 is 2. So it's negative 2. So we go over 2 and we go down 2 units. We do the same on the other side. I'm going to jump, instead of doing 3, we're going to use the value of 4, just because it'll be an easier one to multiply by. So I go back to the vertex. I go over 1, 2, 3, 4 units. What's 4 squared? Times negative 1/2. Negative 8. So we go over 4, 1, 2, 3, 4, and we go down 8 units. Okay, over 4, down 8 units. And you'll notice this is a little wider than the parabola we have above. This one has been compressed compared to our other value. So let's pause that. So here are most of the parabolas on our page, this being our original one. Okay? Over 1 up 1, over 1 up 3, over 1 up 5, or we square the values. When we have the 2 value, you'll notice this is a thinner parabola. It's been stretched. I want you to think of it like an elastic band being pulled from the top. It's thinner than our original. Okay? If we were to flip, this would be the original parabola just with a negative 1 value. So all the same movements just facing downwards because it's negative. And if we put a value of a half, so something between 0 and 1, we get a wider parabola. You'll notice this is wider than the other one. Think of it compressed, like pushing an elastic band down. So you notice all four of these have transformations or movements. They look thinner or wider than the original being always our x squared. Why can't I see?